The Pythagorean Identities. Before we get into more trigonometric identities, let's bring back the unit circle from our last video. We have our circle with a radius of 1 and our right triangle bounded by the radius line. The x-intercept a point P, and the x-axis. Our reference angle, theta, is bounded by the x-axis and the radius line, which is the hypotenuse of our right triangle. But let's focus our attention on our right triangle and recall the Pythagorean theorem. Meaning, a squared plus b squared is equal to c squared. If we equate a to the opposite side of our right triangle, b to the adjacent side, and c to the hypotenuse, then the sine of theta squared plus the cosine of theta squared is equal to 1. Thus, we have the first of what is commonly referred to as the Pythagorean identities. From our first equation, the sine of theta squared plus the cosine of theta squared equal to 1, we can derive our second identity by dividing the first equation by the sine of theta squared. Thus, we have the sine of theta squared divided by the sine of theta squared equal to 1. The cosine of theta squared divided by the sine of theta squared equal to the cotangent of theta squared, and 1 over the sine of theta squared, which is equal to the cosecant of theta squared. For our third and final identity, we can derive it by dividing the first identity, this time by the cosine of theta squared. We have the sine of theta squared divided by the square of the cosine of theta equal to the tangent of theta squared. The cosine of theta squared divided by itself equal to 1, and 1 over the cosine of theta squared, which is equal to the secant of theta squared. And there you have it, the Pythagorean identities. If you like this video, press that like button and subscribe. Thanks for watching.